The functioning of MOSFET depends on the mechanism of MOS capacitor, and it will be easier for you to understand the concepts if you have clearly understood the topics of previous unit MOS capacitor. MOS capacitor in itself may not be a very useful device, but little modifications in it provides us a very useful device that has completely transformed the electronics industry. Consider the shown MOS capacitor. Now, applying any voltage greater than threshold voltage will induce a layer of inversion charges. Since I have taken p-type substrate, so electrons will be the charge carrier components present inside the inversion layer. Now suppose we introduce two degenerately doped n-type region within p-type substrate at the end of this inversion layer and introduce a potential difference between these two regions. This potential drop across the ends of inversion layer provides the free electrons a path for the movement, thus constituting a current. This is how a MOSFET is constructed. Basically, MOS capacitor does not conduct current, but MOSFET does. MOS capacitor is actually considered as the heart of MOSFET, as MOS capacitor actually provides the charge carriers required by MOSFET. M in MOSFET is metal, O is oxide, S is semiconductor, Fe is representing the field effect caused by introduced electric field by the external battery, and T, the transistor. The transistor is a semiconductor device consisting of 3 or more terminals which are used for amplification or switching of electronic signals. These two degenerately doped n-type regions are called source and drain. So, in total, we have 4 terminals, unlike BJT where we have 3 terminals. In MOSFET, we have gate terminal, body terminal, which is also sometimes referred as substrate terminal, source terminal and drain terminal. However, in BJT, we have emitter, base and collector. MOSFET is a symmetrical device. The word symmetrical can include a variety of properties, but here it simply refers to the fact that drain and source terminals are interchangeable. BJT, on the other hand, is not symmetrical. As you have seen, there is a significant difference in the doping of different regions. BJT is a current-controlled current source device, whereas MOSFET is a voltage-controlled current source device. Controlling voltage parameter is the voltage difference across the gate to body, which introduces the inversion layer, and the current is drain current, which is ideally equal to source current. In the shown diagram, there are 2 applied voltages, one between gate and body and the other between drain and source. But this arrangement is rarely used. In general, there is actually no battery directly attached between gate and body. Actually, body and source terminal are generally shorted, and a battery is connected between gate and source terminal. Therefore, the voltage difference between the gate and body is now equal to the voltage difference between gate and source. We know that we want potential difference between gate and body terminal for creating inversion layer channel. But now, since source and body terminal are at the same potential, we can also say that potential difference between gate and source terminal will also create an inversion layer. This is generally followed in almost every standard textbook, and this is done to reduce the number of effective terminals from 4 to 3. However, at the end of chapter, a small topic is also there, generally in the name of body effect, which discuss about what will happen if body and source terminals are not shorted. Since in most cases we usually short the body and source terminal, we can say voltage difference between gate to source terminals is responsible for creating inversion layer. But this is not a statement which is true for all MOSFET. While reading textbooks, you should be very careful. This subject is a theoretical plus numerical type subject. You should read at least 2 different textbooks and solve one textbook as well as the previous year questions for the exam which you are preparing for. A little modification can also be done in the diagram to make it more practical. In a printed circuit board, generally there are no batteries. There is a single voltage supply which supplies power to all the smaller components within the PCB. There are in total 8 different symbols of MOSFET which you should know. Shorting of body and source terminal is so common that we have separate symbol for this particular case. The dashed line MOSFET represents enhancement type MOSFET, as you are supposed to draw or extend the line segments to form a single line. Similarly, you have to put an external voltage in the enhancement type MOSFET so that an inversion layer is created. However, in depletion MOSFET, inversion layer is already present even when no external battery is applied. You should remember these symbols, as sometimes direct questions also come in state level examinations. I don't think you can recall what is the symbol of solar cell. So, a very simple question can become a difficult one if you are unaware of that. I hope you have enjoyed this lecture and are able to connect how MOS capacitor is related to MOSFET.